Topic number 2.1.4a, Tracing in Algorithm and Tracing Table. What is algorithm tracing? Algorithm tracing means manually simulating the execution of an algorithm. You have to run the algorithm manually and check the status of the variables. In this way, you can track the errors and you can find out the stored value inside the variables, also known as desk check or dry run. We are giving a name, that is dry run. Sometimes in the exam they are asking dry run this program. It means you have to write the trace table or you have to show the working of the variables, how values are changing inside the program. Help verify logic before writing the code. Tracks variable changes step by step. Most important thing is that variable changes step by step and help detect logical error. This is the biggest point is there, that is detection of logical error, because syntax error can be traced out by the compiler or interpreter, but logical error are not detected by the translator. So you have to find the logic, you have to trace the changes of the values in the variables, and then you have to find out the logical errors. Steps in algorithm tracing. Number one is, first of all, understand the algorithms. Read instructions carefully and identify the logic flow. Number two, choose test input. Select simple input values to run the algorithm. If the inputs are very long, for example, written x 1 to 100, no need to go 1 to 100. You can test within 5 values, x equal to 1 to 5. Initialization, set variables to their starting value. First of all, you have to set the initial value. Initialize the value to the variables and then move to the next according to the execution of the program. Trace each step, record variable value, okay, perform the instructions, update variables, and follow control flow. What you will do, follow control flow, how control is moving from one line to another line, and if something is looping is there, then you should know that what does mean of loop. If any conditional statement is there, and you should also know that what does mean of these conditions, loop, conditions, and jumps. Repeat until completion. Continue tracing until the algorithm ends. Verify output, checks whether the final output matches the expectation. What is trace table? A trace table records each step of the algorithm, values of the variable at each step, how values are changing in the variables we can see in the trace table. Any produced output, if output is displayed, then they can also displayed on the trace table. It helps check correction of logic, identify logical error, and understand program flow. Suppose here one example, I have written pseudocode and trace table. I will execute one by one, line by line. Okay, first of all, I'm going to run line number 1, that is step number 1. And number will get value 3, and value of x is not there, output is not there. Okay, next we are moving to line number 2. This is line number 2, step number 2. And in this step, we are going to print number. The value in number is 3, so we will put 3. Okay, next line number 3, I'm going to write line number 3. In line number 3, for x from 1 to 3, okay, value of x is 1. Value of x is 1. It will move to 1 to 3. Line number 4, number will get the value number plus 5. In existing value of number is 3 plus 5, it will get 8. 3 plus 5, 8 on line number 4. Line number 5, print number and number value is 8. Okay, that is line number 5. Line number 6, from here it will move to the again on line number 3, and here it will increase in 1. Value of x is 1 to 3, mean here step is step 1. If I did not mention anything, it will be step 1. Okay, mean value line number 3, the value will become 2. Value of x will become 2. Okay, then moving to line number 4. In line number 4, number equal to number plus 5, and previous value of number is 8 plus 5, 13. Number is 13. Line number 5, print number, that is 13. Okay, then we will go to line number 6. Line number 6 will return back to line number 3, and no value of x will become 3. 3 on line number 3. Value of x is 3, and value of x will become 3. And then we are moving to line number 4. Line number 4 is number equal to number plus 5. Previous value of number is 13 plus 5, it will give you 18. Then print line number 5, print number. Now they will print in output 18. Okay, line number 6. Okay, and it will move to the next. No value of x will exceed, that will become 4. Okay, but it will move till 3. Okay, that is condition will false, and then they will move to the next line. Next line from 3, 4, 5, 6 will be skipped, and next they will move to the line number 7. Line number 7, they will print this question mark. Okay, this is a way to write the value of variables in a trace table. Next, moving to the second example. Okay, in second example, I'm going to start. Step 1 is there. Okay, number 2, set c equal to 1. Value of c equal to 1. Step number 2, value of c equal to 1. Value of c equal to 1. And step number 3, read n. I have given n equal to 2. You will write 2. Okay. Step number 4, m will get value from n and c. N contains 2, c contains 1. 2 times 1, that 2 times 1 means 2. That will store in m on line number 4. Mean 2 will store in m on line number 4, step number 4. Step number 5. Step number 5 is print m. The value of m is 2. They will display here 2. Then moving to line number 6. Line number 6, c equal to c plus 1. Mean value of c will become 2. Line number 7, they will check that repeat step number 4 to 6 while c less than equal to 5. Okay, value of c is still 2, not less than, it's less than but equal to 5. It is less than, that's why it will true. Okay, c is mean value of c is less than equal to 5, and mean 2 less than equal to 5 condition is true. Then it will repeat step number 4, 5 and 6. Okay, we are moving to step number 4. Step number 4 is m equal to n times c. Value of n is 2 and value of c is 2. 2 times 2, it will give you 4 and 4 will be stored on M. Okay, on line number 4. Next we are moving to line number 5. In line number 5, print M and value of M is 4. Okay, next they will move to line number 6, increment in 1. Okay, value of C will become 3. Okay, on line number 6. Line number 7, they will check that 3 is less than equal to 5. Yes, they will move to line number 4. On line number 4, they are checking n times C, and n is still 2. Okay, 2 times 3, it will give you 6, and 6 will store in value of M. Line number 5, they will display the output, that is 6. Then we are moving to the next line. Next line is line number 6. They will increment 1. Line number 6. Line number 6, increment of 1. No, value of C is 3. No, it will become 4. Okay. Then we are moving to line number, because previous I have written here. Okay. Next, line number 7, they will check that 4 is less than equal to 5. Yes, then it will move to line number 4. In line number 4, value of n is 2. Value of n is previously 2. You can see that value of n is 2. Mean 2 times 4, it will give you 8, and 8 will be stored on M. Okay, I am mentioning the previous value of n is 2 for your reference. Okay, now you are going to line number 5, and line number 5 output is 8. Now line number 6, value of C will become 1 more, that will become 5. Value of C is 5, and then it will move to line number 7. Repeat 4 to 6 if meanwhile 5 is less than equal to 5. Yes, it's not less but equal. Okay, it will run it again. It will go to line number 4. Line number 4 contains n times n. Value of n is 2. Value of C is 5. Mean 2 times 5. It will store 10 in M. Okay. Then it will move to line number 5. In line number 5, print the value of M, that is 10. Okay. Now it will move to line number 6. Line number 6. Value of C will become 6, and it will check that repeat step 4 to 6 while 6 is less than equal to 5. It is not less, it's not equal, because value of 6 is 6. Now line number 8, it will be end, and this is the trace table. Okay, you can see the output like this. Okay, I'm starting from this slide to next slide. Okay. Next summary is tracing helps verify an algorithm before coding. Okay, tracing table record variable updates step by step, as you know that. Useful for loops, conditions, and debugging the logic, because logical error can be detected by this way, by using the changing the values in the variable, by see the what happened in the variables and why answer is wrong. Essential for understanding program flow. Question number 1. Tracing an algorithm means what? Writing a code, manually simulation steps, and drawing flowchart, printing values. Manually simulating steps. Question number 2. A trace table records only output, only variables, variable changes per step. That is the correct option. Question number 3. Initialization mean encoding the program, choose input, setting initial variable values. That is the correct option. Question number 4. Which step update variables? Understand algorithm, trace, each step. Choose input, verify output. Trace each step. Question number 5. The purpose of tracing is to detect logical errors, compile code, display graphical user interface, delete variables. No. Detect logical errors. 6. Which column is not part of a trace table? Step, output, variable values, computer RAM. This is not a part of trace table. Question number 7. Trace tables are mainly used for formatting text, dry running algorithm, network configuration, file transfer, dry running algorithms. Question number 1. Write pseudocode for a loop that prints the first 5 square numbers, then create a trace table showing all variable changes. I have done here. Okay. I am going to start here. Start line number 1. Okay. Then line number 2. For I 1 to 5, value of I is 1 and it will move to 5. Line number 3 is square I times I. 1 times 1, answer is 1, it will store into square. Line number 4 is print square. Okay, mean output means square value of is 1. Then it will move to line number 2. Line number 2, value of I will become 2. 2. Then line number 3, it will store into square. 2 times 2 mean 4. Then print 4. Line number 4, they will print 4. Then it will move to the next line number 2. Line number 2, value of I will become 3, and next they will go to line number 3. They will store value into square. 3 times 3 into 9, and then they will move to next line, line number 4, and then print square 9. Okay, so in this way it will move to line number next step, one more step. Okay, now I'm writing here because table is space is less. Okay, next line number 2. In line number 2, for value of I will become 4. Value of I will become 4, and value of square will become 16, and then they will display in output 16. Okay, next value of I will become 5. Value of square will be computing 25, and then they will display 25. I skip 2-3 steps. Okay, but if you have a space, you can continue in this way. Moving to the next. Okay, another trace table is there. For x equal to 2, step number 1. Okay, step number 1, value of x is 2. Step number 2, value of y equal to 3. Step number 3, for I will move from 1 to 3. Value of I is 1. Okay. Step number 4, they will compute x plus y and will store into x. Mean 2 plus 3, 5, and 5 will store into variable x. And line number 5, print 5. Then line number 6, and for it will return from this line to line number 3, that is for they will go to line number 3 and they will write value of I will become 2. Okay, then they will move to line number 4. In line number 4, they will check that value of x is 5 plus value of y is 3, that will become 8 in x. Line number 5, they will print value of x, that is 8. Okay, after this they will move to line number 3, value of I will become 3, that is the last time. Okay, last value, it will not move to 4 because they have written from 1 to 3. Okay, then they will move to line number 4. In line number 4 they have written x plus y x value is 8 plus y value is 3, 11, and 11 will store into variable x. Okay, and line number 5 they will display print x, that is 11. Okay, this is the output of this pseudocode. Task number 3. Okay, line number 1 they will start the program. Okay, in line number 2, read n, value of n equal to 4, you have written 4. Okay, line number 3, sum equal to 0. Line number 4, I from 1 to 4, value of I is 1 and it will reach till 4. Okay, 4, 1, and then we are moving to line number 5. Line number 5, sum equal to sum plus I, value of sum is 0 plus I 1, it will store into 1. 0 plus 1, it will store here 1. Next, line number 6. In line number 6, print sum, mean it will display 1. Then from line number 7, we will move back to line number 4, and line number 4, value of I will become 2. Okay, line number 5, sum equal to sum plus I. Last time sum contains 1 plus 2, it will give you 3, and 3 will store into variable sum. Then it will move to line number 6, print sum, value of sum is 3. Then it will move to line number 3. In line number 3, value of I will become 3. And then line number, actually it was line number 4. This line number 4. Then we'll move to line number 5. Line number 5, sum equal to sum plus I. Previous value of sum is 3. No, value of I is 3 plus 6. It will store into sum 6. Next, line number 6, they will print sum. Value of sum is now 6. Next, it will move to line number 4. Line number 4, now value of I will become 4. Okay, then we'll move to line number 5, sum equal to, now value of sum, previous value of sum is 6 plus 4, 10, it will store 10, and then print line number 6, 10 into the output. 10 into the output, and after this it will not move to the line number 4 because it will move till 1 to 4. Value of I will become 4. Okay, this is value of I is 4. Okay, and after this it will goes to end. Okay, this is the trace table. If you have any doubts, you can ask me.